Okay, I'm here to talk about foreign function invocation and making cross-engine Ruby gems. So my name is Jeremy Hinegardner. Some of you may know me, some of you don't. Little intro. I also go by Copious Free Time here and there. We do a little bit of Fedora packaging, Nginx, HA proxy. Anybody use any of those? Raise your hands. All right. And I have a few Ruby gems. Some people use them, some people don't. I do. I have a small confession to make. I love Ruby. Everyone else who agrees with me? Come on, come on. All right. I'm not ashamed to admit it. I also have another confession to make. I like C. Come on, there's some of you. I know there's some of you. Yeah. D, okay, we've got a D fan here. Any B fans? C++, B, all right. F, C++. Anyway, so liking Ruby, or loving Ruby, liking C, I end up writing some extensions here and there. So, are there any extension developers in the house? Raise your hand if you've written an extension. A dozen maybe. Okay, so this is generally targeted for extension developers, but everybody's going to learn something cool today. So who has used FFI? 1, 2, 3, 4. In Ruby or outside of Ruby? In Ruby? Ruby? Okay. Has anyone used FFI outside of Ruby? All right, we've got Pascal FFI. We've got, what'd you use yours in? Okay. So we've got some people who've used FFI. So raise your hand if you've heard of FFI. More general. All right, cool. Raise your hand if you haven't. Brand new. That's about half of us here. So everybody gets to learn something cool. So what is FFI? Well, FFI stands for Foreign Function Invocation. And it's a way for a program written in language A to talk to a program written in language B, and generally at runtime. So the general way that this works is you have, say, libsomething.so. Everybody got .so, or .dll, or .dylib if you're on a Mac. Most of us are. And you have some application that wants to call some method that's in, or function that's in libsomething, called libsomething.foo. So the general way we do this is we compile against it, link it, and run it. Well, sometimes you get into a situation where libsomething you don't have the header files for. Who's ever had that problem? Yeah? Okay. Or libsomething only runs on an ARM processor and your development environment is on x86 or something along those lines, but you actually can't compile against the library you want to run against. So this is where libffi comes in. Sits in the middle. It basically understands all the function calling procedures for a bunch of different architectures. So you can have your code tell libffi, I want to attach to libsomething, and I want to call function foo. And then when it's at runtime, your application will do this. libffi will take your parameters, marsh it all up into the appropriate call stack for your system, and then invoke the function on libsomething.so. Now, this actually has a really good correlation to Ruby. Does this look familiar to much folks? So you've got libsomething.so, you've got the Maths Ruby interpreter, and you have your Ruby app sitting inside of it. So, but say it's like SQLite or Nokogiri. Who uses Nokogiri? libxml Ruby, any of those kinds. Well, they all have a Ruby extension that sits in between the actual libxml file or SQLite or Ruby GNOME that we heard previously, and it knows how to talk to the library, and it knows how to implement methods and functions in the library in the actual Ruby API. So that's how we generally do things. And this works great. We have a lot of them. Now, we do have a problem. What happens when you add JRuby, Rubinius, maglev, any of the other Ruby implementations that are possibly out there? They don't work this way. So we've got JRuby. It can't use the CRuby extension for the Maths Ruby interpreter. The Rubinius one, I haven't played with near as much, so someone correct me if I get this wrong. It can't use the CRuby extension for Maths Ruby. It can? Awesome. Okay, awesome. But we do have this situation. So what do? Well, we get rid of the CRuby extension. And then we say, let's treat Matt's Ruby just like JRuby and Rubinius, and we slide in FFI. So this, both JRuby and Rubinius ship with FFI, Lib Ffi, the one that was on the previous page, where and Matt's Ruby, thanks to the JRuby guys and Wayne, they have developed the FFI gem for Matt's Ruby, which basically is a Ruby C extension for Matt's Ruby that binds to Lib Ffi. So, yes, cheers. Now here's the fun part. We slide in a pure Ruby description and mapping of the lib something methods, functions, structures, and all of that in pure Ruby. And then we're allowed to say, okay, I've got my application. It needs to talk to lib something, and it only does it in Ruby. So we have this shim here between FFI and my application that describes the Ruby interface to lib something, and it can be used by every single one of these interpreters. Now think about that for a minute. That means your application, potentially, without any changing, could run in every interpreter. How's that sound? You know, you're writing an application, someone else is going to deploy it. You don't know who, you don't know where, you don't know how they're going to deploy it, but it's going to be done in Ruby. Maybe they're doing maglev, maybe they're doing Ruby Enterprise, maybe they're doing JRuby, maybe they're doing Rubinius, and your application could potentially run in every single one of them without any changing. So, I'm going to do a little trivial example here. Does anyone use the high times gem? That's one of mine. It does some low-level timing type stuff. But one of the things I have in it is a stats collector that just keeps a running total of counts, distances, sums, all that kind of good stuff. This is a small piece of it that I kind of ripped out for this example. So I'm calling it simple metrics. And what it does, it just keeps track of some stats as we're running along. And we have a structure, which has a min, a max, a sum of squares, and a count. And I actually pulled this whole idea out of the rfuzz gem. And then we have some methods. These are kind of contrived. You know, normally you could just in C say, hey, I want to access the max value from the structure, but we're going to try to do this in an object-oriented C type way. So we have a new, a free, and then and an update to update our whole system, and then accessors. So mean, min, and max, and sum, and count, or min, max, sum, and count just pull straight out of the structure, and mean, standard deviation, and rate actually do a small calculation to return a value. Now this is at the, call it lib something level. So this is straight C, anybody could use it. And this is how we want to use it in Ruby. We want to say, I've got a class called metric. It's got an initializer with name, and then I've got essentially a mapping of those same functions in C to these methods on metric. Everybody see where we're going so far? Now normally, if we did it in a C extension way, this would be probably the last function in your C source code file. We'd initialize the simple metrics, and this describes in the Ruby C API how you go about defining a metric class with an initializer and all of these methods. Some of this looks familiar to folks? Written extensions. Now this is pretty cool, except right there. You know, it's not much. This is a really simple C extension, but it's still 100 and some odd plus lines of C code. Well, okay, not too much, but this is a really trivial example. This is how we do it in Lib Ffi, or using the FFI gem in Ruby. So we essentially have, at the top, we say, hey, my module is simple metrics. I'm defining the FFI interface for simple metrics, and simple metrics has a structure. The first, it's basically laid out, and this describes layout. It's got min, max, sum of squares, they're all doubles, and counts along. Normally, the basic way you would do an FFI is an FFI struct instead of a managed struct. But a managed struct allows you to attach essentially a deallocator to your class. So you can say, hey, when an instance of this object runs out of scope, call release, and you can delegate this to the C level and say, hey, I want you to free up the memory that's used here. Now here's where the magic happens. You have this module FFI, and you want to say, I want to extend FFI library. Now this comes from the FFI gem or JRuby, Rubinius, wherever you are. And that adds in a whole bunch of new things. It's like inheriting from active record base, something like that. It adds a bunch of class methods and does some cool magic. You call FFI lib, which says, this is the library I'm going to attach to. In this case, we're going to attach to lib simple metrics. Now, FFI will go ahead and find the appropriate library if it's in your one of your LD shared path or your lib path or something like that, or you can actually list the exact file and it'll load it too. And then we say, okay, now we're going to define all the functions that are in simple metrics. And we do this a pretty simple way. We say attach function. We have the library function name as a symbol. And then there's two other parameters. One is an array of all the function parameters. And then the third parameter is is the return value or return type of the library function. So in this case, we've got simple metrics new, which takes 0 parameters, returns a pointer. It's an allocator. We've got simple metrics free, which takes the pointer, returns void. So in this case, the result from simple metrics new is what we would intend to pass to simple metrics free. And actually, it's the same all the way down. That pointer that we want to pass to each one of those is the value that was returned from simple metrics new. And then this is that purple shim that goes above the libffi, or it's with that same piece right there. This is providing the actual metric class to Ruby. This is going to use our FFI description and create a metrics class in the way that we want it, with an initializer of name and then accessors for update, min, max, mean, sum of squares, all those types of things. And so we can compare the two. On the left, we have there the Ruby FFI description language, DSL. And it says we've got a layout, min, max, sum of squares, and count. And then on the right, we have the C, corresponding C. They're very close. And then here is a comparison of the actual method definitions from the .h file, or declarations from the .h file, and our use in the FFI code. And basically, they're exactly the same. They look very, very similar. And I can't remember if it's been published yet, but there's actually a generator from FFI that will take your C header files and try to generate the actual C library, the top piece there, from the bottom piece. So I did this. I ran it, tried it a little bit, and I essentially came up with some meaningless metrics. I kept track of how much time it took me to actually write all of this. So the actual lib simple metrics source code, that .c stuff, took me about an hour to write. I pulled it out of another piece of code and put it in here, wrapped it up, tested it, made sure it all worked. Then I did the FFI version. Took me 40 minutes. This was, and I had to look at some documentation, figure a few things out, remember how to do a couple of things. And then the actual traditional C extension, which I'm fairly familiar with, by no means an expert, but that took me 70 minutes. So right now, my personal time, I've saved a half an hour just by using FFI. Then I said, well, let's actually do this with 1 million calls. So we've got 1 million calls, and this is actually where I saw a difference. It's almost 3 times slower to do the call stack through FFI than to do through a traditional C extension. And this is, somewhat expected. Instead of having your class defined in C and then just going straight to the library, you actually have your class in Ruby, which then goes through the FFI extension, description, which then goes through libffi, which then goes through down to the lib. So you've got a couple extra layers in there, and it does have some overhead. And in this case, all this really measures is the overhead. There's virtually no calculation done under the covers in the lib simple metrics. It just adds a couple of doubles, which is pretty trivial. So if you actually do some calculations in the library you're talking to, or it does a lot of heavy I/O or something like that, you probably won't even see any differences here. And then, of course, the important part is, will it blend? And in this case, yes. We can take this FFI library that we just did, and we can dump it straight into JRuby, or invoke it with JRuby, and it'll work. With the C extension, it won't. And this is just a screenshot of what I did. So we have the benchmark from straight Ruby, going through FFI, and going through the extensions, and then the exact same piece of Ruby code, running it in JRuby. And this was the 1.2 release candidate 1, I believe, just the other day. And you can see that it kind of fits in the middle, but the fun part is you do see the speed up from the JVM here. You know, the first, when the rehearsal goes, it builds up, the JVM learns about what it needs to do to get faster, and then when you actually run the benchmark, it falls kind of right in the middle between our traditional extension and a straight FFI call, which is about kind of what you expect because the JRuby stuff is actually, it cuts out one more layer. So, everybody excited about FFI? Yeah? Yeah? I think it's a very cool technology. So, how many FFI gems are there right now? Come on, get a guess.
5.
5? 0?
42.
What?
42.
42. Well, 5's actually closer. I looked at this last night. There are exactly 4 gems that either depend on FFI or use FFI.
Did you count the one that you showed?
Mine?
Yeah.
No, it's not a gem.
Oh.
See, I haven't published it, and it was an example. Yeah, I can. Yeah. Here they are. 5. Okay. You just wanted to be. Yeah. Okay. We all have that problem on occasion.
The Lib Ffi wrapper for OpenGL.
Yes, I do remember seeing that one. Apparently, it hasn't reached the gem servers yet. So yes, no, I saw that one, and I was excited about that one too. So maybe 5 is the correct number. But here they are: FFI ncurses, swig generator, zlib, and one that wraps libtidy, which is kind of cool. I didn't even know about that one. So you know, we've got a good start. Now here's the question. Out of last night, I ran it. There's 4,501 gems on RubyForge. How many of them have extensions?
5.
5. Okay. Come on, I need a better answer than that. 42, 2,000. Over half? 346. So that means there's lots of room to improvement. Oh, come on, where'd that go? Huh? There's a lot of C code in Ruby, but that also means there's 342 gems that we could wrap and that would be immediately available in JRuby. All right? So here's my task for you. Start doing it. We need more of them. We need, you know, we're trying to take over the world here. So as much of this library code that we can get to be available for every other engine, that's a good thing. So the big part of this is we've got some thanks to do. For Wayne Meissner from JRuby, he did Lib Ffi in JRuby and gave it to the Matt's Ruby interpreter too. We owe him a huge thanks. Is he here? No? And Evan is using Lib Ffi in Rubinius, so all of this stuff is available in Rubinius all. And the Kenai wiki, which is where the home project for Lib Ffi is, there's actually a bunch of non-trivial examples on there that show you some more inner workings, how to actually say, I want to do a memory pointer, I want to do some crazy callbacks. You can do callbacks with Lib Ffi, so you want to register an error function, that kind of good stuff. So it's all in there. And there's not a lot of blog posts out there yet. This is pretty much the most of the ones that are available. Hedius, Charles Nutter, this is his first one was the announcement for Lib Ffi last October for JRuby's Lib Ffi. I believe Lib Ffi was put in Rubinius last January. Is that correct? Do you know, Brian?
It's pretty old, actually.
It's pretty old, yeah.
Evan kind of worked on the AI. Charles liked it. So.
Yeah, I'll repeat that. So using Lib Ffi pretty much comes from Evan, and Charles liked it, and Wayne liked it, so they added it to JRuby. So they basically decided on what is the FFI version 1.0 protocol, if you want to call it that. And this is it. So it works. It's pretty good. And then Wayne has his own blog. And there's a few other blog posts that are out there that talk about some of the basics, and it's pretty good. I like it a lot. So I've actually gone fairly fast. So let's go for some questions, comments, discussion. Who do we have? Yes.
So things like by reference arguments, you're going to have to jump through a certain amount of hoops. And that's not the question.
Okay.
Do you know if MacRuby is following that protocol for those hoops or calls down into Objective-C?
I have no clue. No, probably not. Actually, that's a question. Is MacRuby, hopefully I believe this will work with MacRuby too. So, yeah.
MacRuby could just use a regular C extension.
Yeah, MacRuby could use regular C extension. That's true.
I saw one of the examples of the swig generator. Have you played around with that?
I haven't played around with it. That one I think just came out within the past month or so. I actually haven't done a lot with Swig. I do the Ruby extension stuff. But yeah, people play with the Swig extension, see what's going on, have some fun. Yeah. Yes?
Is JNA something that's equivalent for Java?
JNI?
JNA, Java Native Access.
Oh, yeah. Actually, I think Wayne is the person who's actually implementing that. I'm not sure. And so don't quote me on this, but I believe Charles was talking about Wayne's actually on the Java team that actually develops that for the JVM. And so they're trying to, push some of that stuff into Java. But I double check that for sure. Yeah. Yes?
Aren't there some pretty significant advantages if the C code misbehaves?
I have no idea. The question was, are there some pretty significant, you said disadvantages if the C code? Advantages if the C code misbehaves?
Yeah, I think you get better crash.
Yeah, the question is, are there significant advantages if the C code misbehaves? And I actually don't know. But hey, I'd love to hear about it. Any other questions? All right. Thank you.